Avogadro's law, proposed by the Italian chemist Amedeo Avogadro in 1811, states that at the same temperature and pressure, equal volumes of gases contain an equal number of molecules. This law contributed to the development of the concepts of molecules and atoms in the gas state. Avogadro's law explains the relationship between the number of gas molecules and the volume of the gas. At constant pressure and temperature, the volume of a gas is directly proportional to the number of gas molecules, and the number of gas molecules is directly proportional to the volume. This law applies only to ideal gases, which assume that gas molecules have no size and do not interact with each other. Avogadro's law finds applications in various fields. For example, it is used to predict the number of gas molecules produced in gas reactions and to understand the properties of gases and measure their volume or density. Additionally, Avogadro's constant, which is derived from Avogadro's law, is used to calculate the amount of a substance and forms one of the fundamental elements of the ideal gas equation. Boyle's law and Charles's law are laws used in physical chemistry that describe the relationships between pressure and volume, and temperature and wavelength, respectively, in the gas state. Boyle's law states that at a constant temperature and amount of gas, the volume of a gas is inversely proportional to its pressure. This law can be expressed mathematically as P1V1 equals P2V2, where P1 and V1 represent the initial pressure and volume, and P2 and V2 represent the changed pressure and volume, respectively. For example, if a gas has a volume of 1 liter at a pressure of 2 atmospheres, increasing the volume by a factor of 2 will cause the pressure to decrease to 1 atmosphere. On the other hand, Charles's law describes the relationship between temperature and wavelength. It states that there is an inverse proportionality between the wavelength of electromagnetic waves propagating through a material and the temperature of the material. This law can be mathematically expressed as lambda equals b, t, where lambda represents the wavelength, b is the Charles's constant, and t is the temperature. Therefore, as the temperature of a substance increases, the wavelength becomes shorter. Both Boyle's law and Charles's law are highly useful in predicting the changes in volume and wavelength of gases under varying conditions. Charles's law can be expressed using the formula V1, T1 equals V2, T2, where V1 and T1 represent the initial volume and temperature, and V2 and T2 represent the changed volume and temperature, respectively. Now, combining Boyle's law and Charles's law, we can derive the ideal gas equation, which relates the pressure, P, volume, V, and temperature, T, of a gas. The ideal gas equation is given by PV equals nRT. Here, P represents the pressure, V represents the volume, N represents the number of moles of gas, R is the ideal gas constant, and T represents the temperature. By combining Boyle's law, P1V1 equals P2V2, and Charles's law, V1, T1 equals V2, T2, we can rearrange the equations to obtain the ideal gas equation. P1V1, T1 equals P2V2, T2. This equation demonstrates that, at a constant number of moles of gas, N, and using the ideal gas constant, R, the product of pressure and volume divided by temperature remains constant. Therefore, the ideal gas equation incorporates both Boyle's law and Charles's law to describe the relationship between pressure, volume, and temperature in gases.